Alright, let's go. Number 10. The Star Trek Teleporter Problem. In 1966, television writers needed a cheap way to get characters from a starship to a planet's surface without paying for shuttle special effects every episode. The solution was a machine that scanned a body down to the last particle, converted it to some transmittable form, and rebuilt it elsewhere. Nobody in the writer's room was thinking about metaphysics. Under classical assumptions about personal identity, physicists and philosophers alike expected this to simply work, matter is matter, and a perfect reconstruction should be functionally the same object that walked into the booth. Continuity of material felt like it should be enough. Then, philosophers actually followed the logic through, and the floor dropped out. If the original body is destroyed and a new one assembled from different atoms somewhere else, nothing physically connects the two events except information. The person who steps out is built from scratch. Derek Parfit, working through this exact scenario in his 1984 book Reasons and Persons, published by Oxford University Press, argued that the sense of the same person continuing might be a comforting illusion with no basis in physics at all. That what actually happens in the booth is closer to death, followed by the creation of a stranger who merely believes he is you. Philosophers propose that memory transfer alone might preserve identity. It doesn't hold, because a memory is not the thing having the experience, it's a record, and records can be copied without carrying anything over. Some argued information itself is the person. That fails too, since information can be duplicated infinitely. And there is no coherent sense in which infinite yous are all equally the original. Every night, when you fall asleep, something like this already happens on a smaller scale, a gap in continuity that you simply don't notice, because there is no you left to notice it while it happens. If a teleporter were built tomorrow and worked flawlessly, would you be reckless to step inside? Or would you already be a version of the same experiment, running quietly every single night? Nobody solved that one. The next case makes it worse, because now there are two of you at once. Number 9. Derek Parfit's branch line case. Parfit spent years at All Souls College, Oxford, trying to formalize what makes a person at one moment the same person as someone at an earlier moment. A problem that sounds almost administrative until you push on it. Standard philosophy of mind, going back to John Locke in the 17th century, held that psychological continuity, an unbroken thread of memory and intention, was sufficient to guarantee identity over time. One person, one thread, no branching. Parfit then designed a scenario that broke the thread cleanly in two. In his 1984 Reasons and Persons, Parfit describes a teleportation device on Earth that malfunctions. Instead of destroying the original and building a replica on Mars, it leaves the original alive on Earth while a fully conscious, fully memory-intact duplicate wakes up on Mars at the same moment. Both bodies claim to be Parfit. Both have every memory up to the second the machine activated. Neither can be dismissed as the fake. Philosophers propose the Earth body must be the real one, since it has continuous physical existence, but continuity of atoms was already established as irrelevant, since your atoms are replaced constantly anyway. Others proposed whichever body existed first counts, but first breaks down at the level of near-simultaneous quantum events. There is no principled tiebreaker. Parfit's own unsettling conclusion was that personal identity might not be what matters at all. That survival is a matter of degree, not an all-or-nothing fact. If a device could split you into two people with equal claim to being you, right now, reading this sentence, which one would be having this thought? Neither branch resolves the question. The next entry suggests you're already splitting, just slowly enough to miss it. Number 8. The Ship of Theseus, applied to neurons. Ancient Greek writers, including Plutarch in his account of Theseus around the 1st century CE, were originally interested in a mundane maintenance question about a preserved wooden ship in Athens, as rotting planks were replaced one by one over decades. Was it still the same ship? The standard assumption in ordinary life is that gradual replacement doesn't threaten identity. Your car is still your car after new tires. Your body is still yours after a haircut. Physiologists later found something uncomfortable hiding inside that assumption. The molecules making up your body, including large portions of your brain's structural material. are replaced on rolling cycles throughout your life, some components turning over in weeks, others in years. You are not the same collection of atoms you were a decade ago, not approximately, but literally, molecule for molecule. Biochemist Rudolf Schirnheimer's isotope tracing experiments at Columbia University in the 1930s, published in his work later collected as The Dynamic State of Body Constituents in 1942, first demonstrated that the body's matter is in constant flux, dismantled and rebuilt continuously rather than sitting static. Some philosophers propose that the brain's neurons are the exception, fixed for life. That fails, while neuron cell bodies are largely stable. Their internal proteins and synaptic structures are rebuilt on the same rolling cycle as everything else. Others proposed identity survives, because the pattern, not the parts, persists. That's the same argument a teleporter would need, and it means the teleporter was never really doing anything unusual. You are already the Ship of Theseus, rebuilding yourself atom by atom, so slowly that you never once noticed the version of you reading this sentence is not built from the same matter as the version that existed 10 years ago. The only difference between you and the teleporter is speed. The next entry asks whether that difference is even the part that matters. Number 7. Psychological continuity theory. John Locke, writing his 1689 essay concerning human understanding, was originally trying to solve a legal and theological problem. How can a person be justly punished or rewarded for actions taken years earlier if their body has changed? Locke needed a criterion for identity that didn't depend on physical sameness at all. Prevailing 17th century assumptions held that the soul or the body was what secured your identity through time, some fixed, unchanging substance underneath the changing surface. Locke instead argued that a person just is a continuous chain of memory and consciousness, nothing more, nothing metaphysically deeper required. Locke's essay explicitly proposed that if consciousness could somehow be transferred from a prince's body into a cobbler's, the resulting person would be the prince, not the cobbler, regardless of whose flesh he was wearing. Under this theory, a teleporter that perfectly preserves memory and personality preserves you completely. Full stop, no loss, no philosophical crisis. Critics proposed that memory itself is unreliable and can be falsely implanted, undermining it as a foundation. Others pointed out that psychological continuity, unlike physical continuity, can branch, as Parfit's Mars case showed, which means the theory has no answer for duplication at all, only for the single copy case it was built to solve. Still others noted memory fades and reconstructs itself constantly even without any teleporter, meaning by Locke's own logic, you may have already stopped being fully continuous with who you were at 5 years old. If the theory that comforts you about teleportation is the same theory that admits you're not entirely the same person you were in childhood, how much comfort is it actually offering? That comfort collapses entirely once duplication enters the picture. The next entry doesn't ask which copy is real, it proves there's no way to ask. Number 6. The Duplication Paradox. Philosophers working through teleportation scenarios in the late 20th century, including Parfit and later writers building on his work, were originally trying to close a loophole in the psychological continuity is enough answer, a tidy solution that worked fine as long as only one copy of a person ever existed at a time. Standard assumption: identity is a one-to-one relationship. You are you, and nobody else can also be you. That assumption is doing more load-bearing work than anyone noticed, because nothing in physics or logic actually forbids a one-to-many outcome. If a hypothetical teleportation malfunction produced two simultaneous, fully conscious duplicates with identical memories up to the moment of transmission, both would wake up equally convinced they were the original, and both would be right by every test available. Philosophers proposed that the identity relation must be transitive and unique. If A equals B and A equals C, then B must equal C. But B and C, the two duplicates, are now having different experiences from the instant they wake, meaning they are not equal to each other, which breaks the entire chain of logic that let either one claim to be A in the first place. Others proposed a lottery, one copy is arbitrarily designated the real one. That's not a solution. It's an admission that identity was never a fact of nature at all. Only a label applied after the fact for convenience. If your identity can be decided by a coin flip after a malfunction, was it ever the fixed, singular thing you assumed it was while you were alive and unduplicated? Physics doesn't just fail to answer this, it actively forbids the copying that would force the question. The next entry is where the universe steps in. Number 5. The quantum no-cloning theorem. William Wooters and Wojciech Zurek, working at the University of Texas and Los Alamos National Laboratory respectively in the early 1980s, were originally responding to a flawed 1982 proposal by physicist Nick Herbert for a faster-than-light communication device nicknamed Flash, which relied on the assumption that a quantum state could be copied. Standard quantum mechanics predicted nothing should stop this. Classical information gets copied constantly, so intuition suggested quantum information should behave the same way. Wooters and Zurek sat down to formalize why Herbert's device would work, and found instead that it couldn't, for a reason baked into the mathematics of quantum theory itself. Wooters and Zurek published their result in Nature in 1982, titled "A Single Quantum Cannot Be Cloned," proving that the linearity of quantum mechanics forbids the creation of an identical copy of an arbitrary unknown quantum state without first destroying the original. Physicist Dennis Dix independently reached the same conclusion the same year in Physics Letters A. Some hoped a cloning device could copy most of a state, excepting small errors. That fails, any attempt to extract information about an unknown quantum state necessarily disturbs it, so partial copying degrades the original rather than preserving it alongside a duplicate. Others hoped this only applied to exotic lab conditions. It doesn't. It's a structural feature of the theory. True everywhere, always. If every particle in your body obeys a law that makes perfect duplication physically impossible, then a Star Trek transporter isn't just an engineering challenge, it may be forbidden at the deepest level physics has ever described, permanently, for reasons that have nothing to do with technology. That law protects you from ever being copied. It says nothing about what happens when you simply stop, briefly, every night. Number 4. Sleep as a nightly precedent. Sleep researchers in the mid-20th century, including Nathaniel Kleitman at the University of Chicago, were originally trying to map the stages of sleep using EEG recordings, work that led to the 1953 discovery of REM sleep published with Eugene Aserinsky in the journal Science. Common assumption, barely examined by most people, sleep is just a pause, like closing a book and reopening it to the same page. Consciousness dims, but something continuous is presumed to sit underneath, waiting. Philosophers who took dreamless sleep seriously found that assumption harder to defend than expected. During deep, dreamless sleep, there is no subjective experience occurring at all. No observer, no continuity of awareness, nothing it is like to be you during that stretch of time. Philosopher Derek Parfit and others writing on personal identity pointed out that if psychological continuity is what secures your identity, and psychological continuity genuinely stops during dreamless sleep, then by that same theory's own logic, a new person wakes up each morning who merely inherits the memories of the one who fell asleep. Some argued the brain remains continuously active, so identity persists physically even without conscious experience. That defense only works if physical continuity is what actually matters, but this same defense was already ruled out for the Ship of Theseus, since your physical material is not fixed either. Others argued dreams provide an unbroken thread. That fails on nights with no recalled dreaming at all, which is most nights, for most people. If the philosophical objection to teleportation is that the entity walking out isn't continuous with the one who walked in, you may be raising that same objection against yourself. Silently, roughly once every 24 hours. If sleep already breaks the thread this quietly, then what actually needs to survive death or replication to count as you? Something did once try to answer that with an accident in a swamp. Number 3. The Swampman Thought Experiment. Donald Davidson, delivering his presidential address to the American Philosophical Association in 1986, later published as Knowing One's Own Mind in the Proceedings and Addresses of the American Philosophical Association in 1987. was originally addressing a narrow technical question in philosophy of language about how people know their own beliefs with immediate certainty. Standard assumption in philosophy of mind at the time: if two beings are physically identical down to the last neuron, their mental states must be identical too. Same brain, same mind, no further argument needed. Davidson introduced a scenario, almost as an aside, that forced philosophers to confront how strange this assumption actually was. He imagined himself struck by lightning and reduced to his base elements, while at the same instant, a separate bolt of lightning strikes a dead tree nearby and, by pure coincidence, rearranges its molecules into an exact physical duplicate of Davidson's body. Davidson's paper argues that this being, later nicknamed Swampman in the secondary literature, would walk out of the swamp, return to Davidson's office, and write identical essays. Yet Davidson insists Swampman would have no genuine thoughts or memories at all, only their outward appearance, because thought requires a causal history connecting mind to world that Swampman never had. Philosophers objected that if the brain states are physically identical, denying identical mental states is incoherent under mind-brain identity theory. That objection has never been resolved, only argued around for decades. Others said the thought experiment is too far removed from reality to trust our intuitions about it at all, which is itself a concession that nobody actually knows how to answer it. If a molecule-for-molecule copy of you, built by chance instead of scanning, would supposedly not really be you, then what exactly was doing the thinking, all along, inside the version of you sitting here right now? One entire school of philosophy claims to have an answer to that. It says the swamp, the memories, and the causal history never mattered in the first place. Number 2. Functionalism's answer. Philosophers including Hilary Putnam and later Jerry Fodor, working through the philosophy of mind in the 1960s and 1970s at institutions including Harvard and MIT, were originally trying to solve a much narrower problem: whether mental states like pain have to be made of a specific biological material, or whether the same mental state could exist in a different physical substrate entirely. Prevailing mid-century assumption, sometimes called mind-brain identity theory, held that a mental state simply is a brain state, full stop, the same way lightning simply is an electrical discharge, not something separate riding along with it. Functionalists broke this apart by asking what pain actually does, functionally rather than what it's made of, and found nothing in the definition that required carbon, neurons, or any particular material at all. Putnam's work on functionalism, developed across papers in the 1960s, including The Nature of Mental States, argued that a mental state is defined entirely by its causal role, its relationship to inputs, outputs, and other mental states, meaning any system, biological or otherwise, that reproduces those causal relationships genuinely has that mental state, not a simulation of it. Critics proposed the Chinese room objection, developed by John Searle in his 1980 paper in Behavioral and Brain Sciences, arguing a system could perfectly mimic understanding through symbol manipulation without any real comprehension occurring inside it. Functionalists never fully answered that objection. The debate remains open in philosophy departments today. Under strict functionalism, though, a teleported reconstruction that reproduces your exact functional pattern isn't a copy of you at all. It simply is you, with no gap, no loss, no philosophical problem whatsoever. If that's true, why does the idea of stepping into that booth still make something in you resist? That resistance might be the most honest data point in this entire list. The final entry explains why no experiment will ever settle it either way. Number 1. The question with no test. Physicists and philosophers working on consciousness studies throughout the late 20th century, including work associated with philosopher David Chalmers at the Australian National University, were originally trying to build a rigorous, testable framework for consciousness, the same way physics built testable frameworks for gravity or electromagnetism. Standard scientific assumption: if a phenomenon is real, it should eventually yield an experiment capable of confirming or denying claims about it, given enough time and technology. Chalmers, in his 1995 paper Facing Up to the Problem of Consciousness, published in the Journal of Consciousness Studies, argued that subjective experience, what it feels like from the inside to be a conscious system, resists exactly this kind of test because every possible measurement only accesses behavior and reports, never the raw experience generating them. Chalmers termed this the hard problem of consciousness, distinguishing it from the comparatively tractable easy problems of explaining behavior, memory, and reporting. Applied to teleportation. The implication is severe. Even a perfect reconstruction that behaves exactly like you, remembers exactly what you remember, and insists with total conviction that it experienced continuous consciousness through the transfer, could still be philosophically empty on the inside, and no instrument, brain scan, or behavioral test could ever tell the difference from the outside. Proposed solutions included measuring neural correlates of consciousness directly. That only tells you correlation, never confirms the presence of subjective experience itself. Others proposed simply trusting the reconstructed person's own testimony. But a being with no genuine experience would testify to having one with exactly the same confidence as a being that actually does. Testimony cannot distinguish the two cases, even in principle. If you stepped into a teleporter tomorrow and walked out the other side certain that you had experienced the entire trip, there would be no way ever for you or anyone else to confirm that certainty was anything more than a very convincing echo. 10 entries. 10 separate routes into the same room. Not one of these ideas needed an obscure fringe theory to get here. Locke, Parfit, Davidson, Wooders and Zurich, Chalmers, all working inside the most rigorously tested frameworks philosophy and physics have ever produced. The unsettling part was never that identity is mysterious at the edges of knowledge. It's that it was never solid to begin with, sitting quietly at the center of the person reading this sentence right now. If you want to see more videos like this, click the video on screen now.